Yo, 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 welcome back. Today we're going to talk about the intermediate value theorem. So, this was on a homework question I gave to my students the night before. And it says, let's say we have this function f of x equals x cubed plus x minus 1. And we want to show that somewhere on the domain 0 to 1 that the value is 0. And so to solve this one, a couple ways we can do it. Well, one, we can't really graph this function. I don't really know what it looks like, and I really can't factor it. So one way we can take a look at it is just looking at the value at the beginning and the value at the end. So I can say, well, what f of 0 is, and that's pretty easy. That just becomes negative 1. F of 1 would become, let's see, 1 plus 1 is 2, minus 1 is 1. So let's see here. Well, we are going from negative 1 to 1. So at some time, we must cross y equals 0. And we can see that graphically pretty easy. At 0, we are at negative 1. And at 1, we are at a y value of positive 1. Messed that up there. So no matter what this graph looks like, if I were to connect this graph, at some point, sometime here, we know that the y value is 0. In between there. So we call this the intermediate value theorem, or IVT for short. And what it basically says is, because we are going from negative 1 to 1, at some time we must cross 0. But there have to be certain rules for it. For one, the function must be continuous. For example, let's say there's a hole here on the x-axis. If there's a hole on the x-axis, then it would never equal 0. So the first thing we have to say is that the function must be continuous. Function is continuous on the domain a to b. And in this case, our a to b is 0 to 1. So that's the first step. Second, I know I crossed 0 because I'm going from 1 to negative 1. So we must say that these two values can't equal each other. That the value at a cannot equal the value at b. In other words, our start value cannot equal our end value. And for example, if I started at negative 1 and ended at negative 1, could we ever really tell if we crossed the x-axis? No, because I know where I started, I know where I ended. And the last one is the most important step. It's the between step. Okay, this is the most important step. That the value we are looking for, the betweenness step, that the value we're looking for, 0, lies between the two values that we got. So 0 is in between 1 and negative 1. And that value is called k. We call it k. That k is the value, or more specifically the y value we want. And so k has to be between, it could equal to, the value at the beginning and the value at the end. And it can equal that too. This is the most important step. So in this case right here, our y, that's like our y equals k right there. So let's take a look. 1, this is a continuous function. 2, negative 1 and 1 are not the same. And 3, 0 is between f of 0 and f of 1. In other words, 0 is between negative 1 and 1. So therefore, we would say at some point on the domain 0 to 1, f of x has to equal 0 by the IVT. We can abbreviate that, the intermediate value theorem. And that's our rule. So let's see here. In other words, let's put this down. In other words, if a function is continuous on the interval a to b, there exists a value, then the values of that function must take on every value between f of a and f of b. In other words, the function has to take values between negative 1 and 1. Every number in between them. even the irrational ones, given that C is in the interval A to B. So, for example, in this graph right here, this is our x value C. At some point, we have to cross at C. And that's what this says, where we cross. Where f of x equals C. We'll talk about that later on in just a few moments. Alright, so for the following, so let's take a look here. Determine if the IVT holds for the given value of k. So this right here, so if we take a look here, we have this rational function. Here's our value of k. So if the IVT does hold, find the number C for which f of C equals k. Now this is the most important part. It's so important, look how they spell it. Okay, if not, we have to say it's a reason. So this is a very important step for us. So we have this rational function, and if I were to kind of sketch that graph right here, we only care about between 2.5 and 7. So if we find f of 2.5, my ink is dying here, I'm going to switch pens here. So if we find the value of the function at 2.5, so I can find that pretty quickly. Well, f of 2.5, plugging it in, that's going to give me 1 minus. Now, this is 2.5 minus 2 is 1/2, so that's 2. So at 2.5, we're way up here at 2. And then I have to find the value at 7. Well, if I plug 7 in, that just becomes 1/4. Oh, sorry, 1/5. That's terrible math of me. So here we are at 1/5, not drawing the scale. Now it's a rational function, so we kind of know what that looks like. So at some point, we're going to have an x value C, and we want to find where that C occurs, and that's what we're looking for. So we know that our value C has to be between 1/2 and 2, and that's what we're out to find. So the first thing we have to do is determine if the IVT holds, and that's really easy to do. 1, so this is part A, so 1, the first step is to find the value. To show that this is continuous, that f of x is continuous on the domain 2.5 to 7. And the answer is yes, that is. This does have a domain restriction, x can't be 2, but we don't care about 2 because we're starting at 2.5. The second step is to show that f of 2.5 does not equal f of 7. Well, we already found the values over here, so 2 definitely does not equal 1/5. Check. And then the third step, is 1/4 between 1/2 and 2? Now, most guys don't know that because we're not good with diamonds and everything, but you girls should be pretty good at this one. A 1/4 carat, sorry, that was 1/5 there, that was 1/5. A 1/4 carat is slightly bigger than 1/5 of a carat. So yeah, 1/4 is between 1/5 and 2. So I'm going to say that 1/4 is between 1/5 and 2. And now I got my answer. Therefore, what this says to us is that the IVT holds. And somewhere, I like to say this, and somewhere, because we don't know exactly where yet, on that interval 2.5 to 7, the value must equal 1/4. So that's very important. Now, every year, people always write down IVT holds on that domain. That's not what they're looking for. IVT holds, and what that's telling us is that somewhere the function has to equal 1/4. It's a sentence. Now, part B is normally the one everybody's going to miss. You're all going to get this wrong on the homework, I promise. Everybody misses this one, okay? For part B says, if the IVT holds, find where it occurs. Where does f of c equal k? This is where. Be careful, this is not c. This is my k value, right? That's my k value. So f of c, really, I don't like f of c, so I just use f of x equals k. And I just plug it in. 1 over x minus 2 equals 1/4. And if I solve that, we get 4 equals x minus 2. Whoop, we're looking 2. X, of course, equals 6. And take a look. 6 is between 2.5 and 7. Oh yeah, so this is good. That is between 2.5 and 7. So we're good. Now the last part is to sketch part C, and we already did that up here. We already sketched that up there. This is what our final answer is. So we know that the Ivt holds, and somewhere the value has to equal 1/4. And we can even tell where it occurs at. In some cases. We can't do it in all cases. For example, if I'm driving my car, let's imagine you're driving your car, right? And you have time and you have miles per hour. I start at 0 miles per hour and I go to 20 miles per hour over a certain time interval, let's say 2 hours. At some point, was my speedometer 10? Yes, it has to be between 0 and 2 because 10 lies between 0 and 20 at some time. On our trip, we had to be at 10 miles per hour. We don't always know when it occurs, but we can tell you that it has occurred. That's Ivt. Alright, so this one's pretty easy. You should recognize this one from the other day. This is our semicircle here with a radius of 2. When we're solving this one, it's good to sketch it. Anytime you deal with a circle, my guess thing to sketch it. If anything else, it tells us about part C. So we know the radius is 2. We talked the other day that this is the top half of a circle. So it's right here. And we want to know, at some point, will the value f of x ever equal 1? That's what that's asking me. And of course this is easy to answer. The answer is, of course, yes. But this is kind of a unique one right here. This is kind of a unique one right here. So, 1. Is the function continuous? And yeah, f of x is continuous on the domain -2 to 2. Yes. 2. Is the value at -2 not equal to the value at 2? And this is where our problem begins. Because here we're saying 0 does not equal 0, which is a false statement. That is definitely not true. Okay, if you think that's true, come talk to me. We'll talk about that. Okay. So even though, take a look here, we know the value has to equal 1. Heck, we can solve it using algebra. Okay. However, we can't prove it by Ivt. So this way, Ivt fails. Failure doesn't mean it doesn't ever equal 1. Failure just means we can't prove it with Ivt. And that's all this means. We can't prove with Ivt. We have to use some other method for it. Okay? Alright, so that's the end of part 1. When you're getting ready to go into part 2, we'll take a look at some other examples.